Today, we will talk about the average rate of change. Now, the main idea here is that the average rate of change is nothing more than the slope between 2 points. And from Algebra 1, you might remember that the slope can be calculated using this formula, where the slope is the change of y over the change of x. Now, again, remember, in order for you to find the slope, you need two coordinate points. So keep that in mind. The average rate of change is the slope, and the slope can be calculated using this formula, which uses two coordinate points. So let's see, how can we apply this idea here? Well, let's look at our first example here. It says, given the following graph, let's find the average. Well, it seems like I'm missing an E here. So an average rate of change for the following intervals here. All right, so we've been given this graph. Okay, so we have this graph, and let's see, it's asking us, well, find the rate of change between the interval 1 and 3. So when they talk about intervals, this is in terms of x. So what this is saying is, look, you have this graph. What is the slope, or what is the rate of change between x being negative, x equals 1 and x equals 3? So where's that at in our graph? So you want to find out the rate of change in this interval from x being equals to 1 all the way to x being equal to 3. Okay, so how do we do that? Well, let's look at the extremes of that interval. So here, this is when x equals to 1. But what is this coordinate point here? Well, this coordinate point is 1 comma 0. So this is what happens when x is equals to 1. Now we got to see what happens when x is equals to 3. When x is equals to 3, you have this coordinate point. Now you will see here that the value for this coordinate point is 3 comma 16. Now just look at here, it seems like every square has a value of 2. So this is 14 plus 2, so that's 16. All right, so we got two coordinate points. We got the coordinate points of the interval. Now if we want to use the rate of change, all we got to do is find the slope. And how do we find the slope? Using those 2 points. So remember, the rate of change, let me rewrite that. So the rate of change is equal to the slope, where the slope is y1 minus y2 over x1 minus x2. But we got two coordinate points. Here we got coordinate points 3 comma 16, and we got another coordinate point of 1 comma 0. So we're going to use these coordinate points to plug it in. Let me call this my y1. I'm sorry, my x1. And let me call this my y1. The same for the other coordinate point. This is my x2, and this is my y of 2. So we got values. We have a formula. Let's find the rate of change. So the rate of change is y1 minus y2. So that's going to be 16 minus 0. So let's write that down. Divided by x1 minus x2. So that's going to be 3 minus 1. Okay, so now let's just simplify this. 16 minus 0, well, that's 16. 3 minus 1, so that's 2. And 16 divided by 2, so that's 8. So this means that the rate of change is equals to 8. Usually you should have some kind of a units here, but they're not giving us any units in this problem. So let's just keep it as this. The rate of change is equals to 8, and that's about it. So now let's look at the next example here. It says now let's find the rate of change between 3 and 5. All right, let me move example A here. Let me put example A to the side because we already have this. And let's actually concentrate on example B now. So example A is done. So now let me erase this because this is all about example A, which it's been done. So we don't need this information anymore. So now let's see. Now they're asking us find the rate of change between 3 and 5. Okay, so let's see what's going on here. Well, again, let's identify the interval that we're interested on. We're interested from 3 all the way to 5. So here's 3 and here is 5. So we're interested in this interval. So let's look at this interval here. Now, if we want to find the rate of change, we need some coordinate points. So let's see what happens when x is equal to 3. When x is equal to 3, which is exactly this point, my coordinate point is going to be 3. My coordinate point is going to be 3, comma, what's that, 16? Perfect. Now we want to see what happens at 5 as well. So when x is 5, we are at this point, and this is 5, comma 0. All right, perfect. We got those values. We have a formula. Let's find the rate of change. So, and let me remind you that the rate of change is equal to y1 minus y2 over x1 minus x2. Okay, so let me get this points. 3 comma 16, 5 comma 0. These are the points that we got from the interval that we're interested on. So now let's label our points here. So let's call this the x1 and let's call this the y1. Let's call this the x2 and let's call this the y2. Perfect. So what do we do now? Let's just plug them in. y1 minus y2. So that's 16 minus 0 again. Okay. Divided by x1 minus x2. So 3 minus 5. Okay. So let's just finish that off. Let's simplify this. 16 minus 0. So that's still 16. And 3 minus 5. This is negative 2. Okay. So, but I mean, let's simplify this. A positive divided by negative. So this is a negative. Let me just write it out here. So this is negative 16 divided by 2. That's still 8. So that means that the rate of change is equal to negative 8. So let's just write this down. Negative 8. And again, when we talk about rate of change, we need to put some kind of a units here. So negative 8 meters per second, or any kind of a unit here. But at least in this example, they don't give us any units in our problem. They just give us a graph. They didn't tell us what x represented or y represented. So just remember that for the rate of change, there has to be some kind of a unit. But in this example, they don't give us that unit. So we're just going to call that negative 8. But keep that in mind. Rate of change should have some kind of a unit on it. So this is the case when the rate of change, when we try to find the rate of change using a graph. But there's also instances where they don't exactly give you a graph, but they give you the function for the graph. So how do we tackle those kind of examples? Well, let's see this example here. It says, given the following information, find the rate of change in the indicated interval. Okay, so we're looking for the rate of change. Perfect. So find the slope of the line going through the curve. So they're giving us this function. Okay. They're giving us the function x squared plus 2 as x changes. So here, this is the interval. The interval is from 3 to 0. Okay, so we have a function. We want the slope, and they're giving us an interval. And again, the interval are what we can consider as the x values here. But remember that for the slope, we have a formula for that, which is y1 minus y2, x1 minus x2. For the slope, if we want to use this formula, we just don't need the x values. We need the x and the y values. So we know the value of x that we're interested. We also have a formula. We can use this formula to obtain the values of y. So what we want to do first is find the coordinate point. Find the coordinate point for 3 and 0. Then we're going to have enough information for the slope formula. And then we can find the slope. So let's do that here. So the first thing that you want to look is we're going to look for the points. All right, so we're going to look for coordinate points. So what is the left side of that interval? It says from 3 to 0, which is the same as saying from 0 to 3. So let's see what happens when x equals to 0. Well, let's plug that in on the formula. When x is 0, we have f of 0 equals, we're going to substitute 0 for x. So we're going to have 0 squared plus 2, where 0 squared is just 0, so 0 plus 2 is just 2. So when x is 0, our y is 2. So this is going to give us a coordinate point of 0, comma 2. Because when we plug in 0 to the function, we obtain a y value of 2. So we're going to do the same for the other point here. So now let's see what happens when x is 3. How do we obtain that y value? Well, let's plug it into the formula. So we're going to have f of 3 equals 3 to the second plus 2. And let's just find out what the number is. 3 to the second, so this is 9, plus 2. So now this is going to be 11. So what this means is that we're going to have a coordinate point of 3, comma 11. Because when we plug in 3 to the function, we obtain an 11 out. So that means that the x is 3 and the y is 11. All right, do we have enough information? Yes, we do have enough information to find the slope now. So what do? We're just going to plug that in. So let's find the rate of change. Okay, sorry about that. The rate of change. And again, the formula is y1 minus y2, x1 minus x2. So, I mean, it doesn't matter which point is x1 or x2. Nah, but I just do left to right. So I'm going to call this my x1, and I'm going to call this my y1. I'm going to call this my x2, and I'm going to call this my y2. Okay. So all we got to do now is just plug that in. y1, well, that is equal to 2. So we're going to have 2 minus y2, where y2 is 11, over x1, which is 0, minus x2, which is 3. So now we're going to have 2 minus 11, so that's negative 9. 0 minus 3, so that's minus 3. Negative divided by negative, so that's a positive. And 9 divided by 3, so that's positive 3. All right, so this is it, the rate of change. The rate of change is equal to 3. And again, we don't have units. There should always be some kind of a units here, but they're not given to us in the context of the problem. So we're just going to call that the rate of change to just be equals to 3. So now, here's your entrance ticket. Given the following graph, find the rate of change for the interval 0 to 4.